Good morning, dear student. In previous lecture, we already discussed introduction regarding to the 18 electron rule. So in this lecture, we are very much interested to count the electron by different methods. So this is the first method, method A, that is ionic method. It is also known as oxidation state method. So in this method, for counting the electrons, you should find out the oxidation state of the metal atom and the formal charge on the ligands and the formal charge on the complex. So, for considering what is this formal charge, first we discuss the formal charge. What is this formal charge? This formal charge, let us consider the example of M L by 6 and it having -2 charge. So whatever the oxidation state of this metal atom, it is considered as a formal charge of metal atom. Formal charge of metal. Formal charge of metal. And then whatever the charge on this ligand, that is the formal charge of ligand. Formal charge of ligand, and this is the charge, formal charge on complex. Formal charge on complex. So the formal charge on the metal, it's considered as oxidation state of the metal atom. And to count the electron, either the species is 18 electron or not, you should first find out the formal charge on the metal atom, that is oxidation state of the metal atom, and the formal charge of the ligands. The formal charge of complex can be find out using the oxidation state of the metal atom, oxidation state of metal, that is the formal charge on the metal atom plus the formal charge on the ligand. Formal charge of ligand. So the formal charge on complex can be find out with the help of oxidation state of metal atom plus the formal charge of ligands. So this is regarding to the formal charge. So to count the electron, you must find out the oxidation state of metal atom, and to find out the oxidation state of metal atom, you must find out the formal charge on ligands. So there are some certain rules, and these rules are very much useful to find out the formal charge on the ligands. We know that whenever we considering a organic ligands which is attached to the metal atom, then the carbon, it is more electronegative than your metal atom. So the electronegativity of carbon is more as compared to the metal atom. So let us discuss some important rules. Important rules to find out the formal charge. To find out the formal charge. To find out the formal charge of ligands. The first important rule is that if there is any alkyl group is attached to the metal atom, so whenever a alkyl group is attached to metal atom, that is transition metal atom, then it should have a -1 charge. Then the carbon must have -1 charge and the metal must have +1 charge. For example, that is your CH3, CS2, CS2 and Fe. So in this case, carbon is more electronegative, so it have -1 charge and the Fe must have +1 charge. Okay, then if you consider a cyclic system, that is, this is the system where the metal atom is attached, and if you find out the formal charge of this system or organic ligands, then it is same as we know that whenever a carbon it is attached to the metal atom, it have a minus 1 charge. So minus 1 charge on this organic ligands, and the metal must have plus charge should be there. But if you consider the another example, that is, this is your species, and when the metal atom it is attached to this organic ligands, and you find out the formal charge of this ligand, then we already discussed, that is, whenever the alkyl group is attached to the metal, it having a minus 1 charge. But if you see, whenever the alkyl group, you should keep in mind that whenever a alkyl group is a part of cyclic system, whenever a alkyl group is a part of cyclic system or is a part of ring, then you should must see the aromaticity before finding out the formal charge. And if you consider with the help of rule first, then we can write this as minus, this as minus, and then this is your metal atom according to the rule first. But whenever there is alkyl group, whenever a alkyl group is a part of aromatic ring, then you should must give the first priority for aromaticity, and then you have to find out the formal charge of the ligands. So we know that whenever there is an even number of bond, then it is anti-aromatic species. Even number of bonds, then it is anti-aromatic species. And if there is an odd number of bonds in cyclic system, then it is aromatic species. So we know that aromatic species is more stable as compared to anti-aromatic species. And if you consider this negative charge, it is involved in the resonance, and it is foreign electron species. For it will follows foreign system, and therefore it is anti-aromatic. So it is unstable. So for whenever a alkyl group it is a part of ring, you should must consider the aromaticity, and it is anti-aromatic. And so even number of bonds are anti-aromatic and odd number of bonds are aromatic. So in this case it is anti-aromatic and it is less stable. But if you consider in this case the complex or not complex, this organic ligand, it is attached to the metal atom, it is not always minus 1 charge when alkyl group is attached to the metal atom. Whenever you considering a ring system, whenever a alkyl group is a part of ring, then we consider aromaticity. So it is not an aromatic, it is not follow the aromaticity, so it is unstable or less stable. But if you consider here a positive charge on this carbon and the metal have a negative charge, then it will follows the aromaticity, because there is only one double bond is there. In this case, if this lone pair is involved in bonding, then there is a two double bond. So the even number of double bonds are anti-aromatic, while odd number of double bonds are aromatic. So in this case there is only one double bond, so it is aromatic and it is more stable, and therefore it is not always minus 1 charge whenever a alkyl group attached to the metal atom in case of ring system. So you should must know, you should first give the priority for aromaticity. So if you get a positive charge on this carbon, then there is only one double bond and it is a aromatic species, it is more stable. So sometimes there must be a positive charge, the positive charge must be sometimes there is a chances of positive charge is also possible on carbon atom to maintain the aromaticity. Let us discuss some important examples, some important. So this is the case. So there is only one double bond, it is aromatic and it is more stable. So this carbon having positive charge for aromaticity. So it is not always a -1 charge. To maintain aromaticity, the carbon must having a positive charge whenever the alkyl group is a part of aromatic ring. Let us discuss some another example. So this is the rule second. So whatever we discuss, that is your rule second. Whenever alkyl group is a part of ring, alkyl group is a part of a ring, cyclic ring system, part of a ring is a part of a ring, then you should see the aromaticity. Then see the aromaticity. Then see the aromatic. Then see the aromaticity. Then see the aromaticity, and the +1 charge is also possible. +1 charge on organic ligand. Organic ligand is also possible. +1 charge on organic ligand is also possible. This is the rule second. So let us discuss some example of rule second. Rule second, for example, if you're considering a very familiar example. So this is your five-membered ring. In this case, so there is a no double bond. So in this case also, this carbon having -1 charge, and the metal should have +1 charge, because there is a no probability of aromaticity. So there is a no double bond is there. But if you consider the structure like this, that is double bond is there, double bond, one hydrogen is there, one metal atom is there. Then if you consider this species, and then you have to find out the formal charge of this organic ligand, then there must have a negative charge. There must have a negative charge to maintain the aromaticity. So in this case, we can write this as this is your negative charge, and which is attached to the metal atom. Because if you're considering this species, there is already two double bond is there, and if you consider a negative charge on the carbon, then there is a total 6 electrons. Total 6 electrons means 3 electron pair is there, and it is an odd number of double bond is there, because this negative charge is involved in resonance, and therefore it is 1, 2 and 3. So this negative charge considered as a 2 electron species, 2 electron, and therefore it is an odd number of double bonds. That is, it is total 3 double bonds, and whenever there is an odd number of double bonds, this is it will follows the aromaticity. That is, it is aromatic in nature. That is, it is in aromatic nature. So the ligand must have -1 charge, because for aromaticity the number of double bond must be odd number of double bonds. So this is about the rule second. Let us discuss the rule third. That is, let us discuss the rule third. Rule 3, that is, whenever a donation of electron by pi bonds, lone pairs, sigma bond and the neutral ligands, then there is no charge on the ligands. So you should remember, whenever a electron donation to the metal atom by pi bonds, if there is an electron donation from pi bonds, second lone pair donation of electron from lone pair. Third, sigma bond, sigma bond. And fourth, the neutral ligands. Then in this case, the ligand does not have any formal charge. So whenever a pi bond contributing the electrons, lone pair contributing the electrons, sigma bond contributing the electrons, they all ligands are considered as a neutral ligands, because this is the rule third, that is whenever the electron donation by pi bonds, lone pairs, sigma bond, there is no formal charge on the ligands and the ligands are neutral ligands. So in this case, there is no formal charge, no formal charge on ligand. So whenever the electron donation from pi bonds, lone pairs and sigma bond, then there is no formal charge on ligands, and these all ligands are considered as a neutral ligands. All ligands are considered as a neutral ligands. All ligands are considered as a neutral ligands. For example, let us discuss some examples of this rule third. That is, first example, that is your ammonia NH3. So ammonia having a lone pair, so it will donate its electron to the metal atom. So whenever the electron donation from lone pair, then the ligand does not have any charge. Therefore, this ammonia, it is your neutral ligand. Therefore, this ammonia, it is your neutral ligand. Similarly, the water is also OH2. It will donate lone pair to the metal atom. It will donate lone pair to the metal atom, and therefore it is also a neutral ligand. So whenever the donation of electron from lone pair, pi bonds and sigma bonds, then there is no formal charge on the ligands and the ligands are neutral ligands. So this is your ammonia water. Okay, whenever another example is the ethylene. So this is your example. This is carbon carbon double bond, and when it donate electrons, so it contribute 2 electrons to the metal atom, or in organometallic complex, its contribution is 2 electrons. So the donation of electron from pi bonds, donation of electron by pi bonds. So we already discussed the rule third, that is whenever the electron donation from lone pair pi bond, then there is no charge, no formal charge on ligand. So this ethylene is your neutral ligand. This ethylene is your neutral ligands. Another example is that when the donation from the sigma bond, for example hydrogen and hydrogen. So whatever the donation, the electron donation by sigma bond, the bond between two hydrogen is sigma bond. Whenever there is electron donation by sigma bond, then the ligand does not have any formal charge. So no charge on the ligand in this case also. No charge on ligand, and this ligand is considered as a neutral ligand. This ligand is considered as a neutral ligand. So but if you consider this species, but if you consider this, that is double bond, carbon carbon double bond is there, hydrogen is there, hydrogen is there, hydrogen is there, but one hydrogen, it is replaced by the metal atom. Then if you see the electron donation, if you see this, in this case the hydrogen, it is replaced by the metal atom, and this is not a simple molecule like ethylene. The donation of electron is not from the pi bonds, and therefore in this case the donation of electron from pi bonds, therefore it is neutral ligand. It is neutral ligand, but if you consider here, it is not a neutral ligand. So this carbon must have a -1 charge. This carbon must have -1 charge, and this metal atom must have +1 charge, because this is your covalent bond. This is your covalent bond. The bond between carbon and metal is covalent, and if you cleave this bond, then whenever the rule first is there, whenever the carbon is attached to the metal atom, then it have -1 charge and metal should have +1 charge. So don't get confused between the ethylene and whenever the metal atom is attached to this carbon carbon double bond, so it must have -1 charge. Similarly, uh, this is, that is, triple bond CH is there, CH is there, and this is your metal atom, then it is also a neutral, because donation of electrons by pi bond is there. If you consider carbon carbon triple bond, so donation of electron from pi bond, so it is your neutral ligand. But whenever you consider this, that is metal atom, it is attached to carbon, and then it is not a neutral, it must have a -1 charge, it must have a +1 charge. So this is all about the formal charge. In the next lecture, we discuss some example and find out the electron count by this ionic method or oxidation state method. Thank you.